everyone. So today's lecture is about Piedmont forests. And so we've spent all semester in the Piedmont of North Carolina. And in a regular semester, we would be going to locations around the Piedmont to show you the different variation that there are in Piedmont forests. So I'm going to present some broad brush categories, but there are certainly different types of Piedmont forests that you can deep dive into. And so we're really just scratching the surface for our Piedmont forests. So this photo is taken in Umstead State Park during a winter snowfall. So before we get started, I want to ask the fiction edition of Tree Trivia Tuesday, what tree played a sentient role in the Harry Potter series? And of course, that is the Whomping Willow. And this is just a quick reminder that trees are losing their leaves now. And so you're going to need to rely on some new tricks to learn how to identify species when they don't have leaves on them. So something to keep in mind for the labs through this rest of the semester. I've come across several trees that I would think would remind me of the Whomping Willow. This one is in the mountains, although it's, I think it's a sugar maple. So this is going to be a relatively short lecture. And like I said, we're going to focus on Piedmont forests and the process that affects Piedmont forests the most, which is forest succession. This is an area where I spent quite a lot of my time in research. I was looking at how Piedmont forests succeed over time with different forest management practices. So that was part of my dissertation research. And we're going to talk about two broad types of Piedmont forests, Piedmont pine oak forests and Piedmont oak hickory forests. And unlike the forests of the coastal plain that we already looked at, these forests are actually similar. One can grade into the next. Big factor here is time. So we're going to start with our lovely photo again from Umstead State Park. This is on the North Cherokee Creek Trail, place that I run most Saturdays. And just a reminder, the Piedmont is in that orange area. So between the fall line, which separates the Piedmont from the coastal plain, and then the Blue Ridge Escarpment, which separates the Piedmont from the mountains and the foothills. So, and that, you know, this is an area that is unaltered, you know, completely altered by land development, logging, agriculture. So very human dominated landscape for the most part. And most of this land has been cleared for agriculture. There's really very few pockets of forest left that do not have some land clearing as part of its history. So that's a really key part. All of our major urban areas are in the Piedmont. So I'm going to quickly flip over to this really cool map of land cover in North Carolina. And you can see it's almost too fine a grade to see all the different forest types. There's too many colors that are similar. You can definitely see the urban areas in red and notice that they are confined to the Piedmont, right? Shown here between the kind of this area, this urban area is Asheville, the mountains, but the rest of this is Charlotte-Mecklenburg. This is the Triad area. And then we have Wake County here with Raleigh and Durham and Chapel Hill. We have Fayetteville here, which is really in the Sandhills area. So something to see and keep in mind there. So most of the Piedmont is urbanized, or much of it is urbanized. And in Piedmont forest, right, so coastal plain forest, we talked about what are some of the major factors that determine one type from another. Piedmont forest, these things are a little bit different. So disturbance and the age of the forest really helps determine what you're going to find in a given place. The soils are also important, and also moisture. And so we're going to talk about each of these things in turn. Topography can also play an important role, although often the important role has to do with moisture and soil depth. And you'll find that compared to the coastal plain, the distinctions among these different community types are pretty subtle. There's a lot of variation with them. You know, I think they will form recognizable community types, and there's certainly a lot more detail to be had. You can recognize different community types within them. We're going to stay pretty broad in our categorization of Piedmont forests, but I do want you to know that there's a lot of variation out there. That variation can be pretty difficult to determine, though, and the different forest types can be a little bit difficult to identify. So just quickly looking at our precipitation map from of North Carolina, this is a pretty old map now, 1998. You can see the Piedmont compared to the coastal plain and the mountains is quite a bit drier. About 45 inches of rain per year in Raleigh is something to keep in mind. So moisture, site moisture does play an important role in determining forest type. And the two types, main types that we're going to look at is a pine oak or mixed hardwood forest. And these are forest types that grade into the coastal plain. So, you know, nobody tells the trees where to live. They thrive where they thrive. And so you'll see that these forest types grade into the coastal plain. There's certainly pine oak and mixed hardwood forests that are found in the coastal plain. We didn't actually get into them. We'll see some when we do forest communities. But we didn't see them when we talked about the coastal plain. And then we have the oak hickory forest, which is a forest type that definitely grades into the mountains. They look a little bit different, and the species composition is a little bit different depending on where you are geographically. But these are recognizable community types where the main species that are present are pines, oaks, and hickories, also mixed hardwoods. And then we have other types found in the Piedmont, some that probably or should be familiar to you now. Bottomland hardwood forests are certainly found in a lot of the river basins that are that come into the Piedmont, and cypress gum forests even come into the Piedmont, which might surprise you a little bit. If you visit locally Swift Creek Bluffs, which is a Triangle Land Conservancy property that is classic bottomland hardwood and a really beautiful one, especially to visit in early spring. And then if you visit Robertson Mill Pond, this is the probably the westernmost, I think it's the only cypress gum swamp or cypress gum forest found in Wake County, or maybe some west of us. And again, these things the factors that are important in determining what forest types you have in the Piedmont are disturbance and age, right? So what is that stand history? What happened on this land before this current forest developed? So that includes disturbance as well as succession. How has that forest grown and aged through time? The soil type can be an important factor, and also moisture. And then lastly, topography can cause some subtle gradations in forest community types. So again, a lot of my photos are from Umstead. A little bit of forest history for the Piedmont. As I said, that human disturbance is really important. 150 years ago, remember the statistic from our first lecture in this series, was that North Carolina is now 2/3 forested. Well, about 150 years ago, North Carolina was a lot less forested. So what land use type do we have? We had extensive agriculture especially over much of the Piedmont. And so you're not going to find old growth forest in the Piedmont of North Carolina. Nearly all of it was timbered and then cleared for agriculture, sometimes both. There's a few pockets where logging wasn't practical or the wood wasn't especially valuable, but for the most part, this is a cut over forest. The land use practices of the time, the agricultural practices, were destructive. There was a lot of loss of soil, and just due to erosion, right? People would clear the land and plow it, not realizing that soil runoff would be really erosive, and then eventually that reduced and lost fertility to these sites. And then, you know, so we had agriculture through the end of the Civil War, and then the economy shifted, right? Without that plantation kind of economic model. And then often, you know, families pulled up and moved. The land was sold very cheaply because the farms were abandoned because of loss of soil fertility. And so a lot of these places, you know, the land was kind of sold off and people moved away, and that land was then allowed to return to forest. So I have a photo here from Umstead State Park. Umstead State Park became a state park during this time of land abandonment, extensive land abandonment. And in fact, Umstead State Park was sold as abandoned agricultural land. It was, you know, pretty crummy land. And you can still see traces of the agricultural history at Umstead. There's some really great walks that the Umstead State Park staff does, where you can go and see traces of old homesteads, and also some of the tilling and furrows that you can see that indicate that this is old agricultural land. these kinds of walks are really fun to do because you feel kind of like a detective trying to understand what was here beforehand. So all of the park, if you go to Umstead and you think, oh, this is a pristine forest, it is not, right? It is a regenerated forest following agricultural abandonment. That's just important to note. And today, or since 1970, we have seen an increase in clearing of land. So we had the forest regenerated. We're now still about two-thirds forested in North Carolina, but development is really now the big pressure on forests in the Piedmont of North Carolina, right? So we have really growing population in the state, and so a lot of forests are cleared for development projects. So you can actually predict what happens when you walk away from a piece of land and allow it to turn back into forest, right? In North Carolina, you do not have to plant trees to get forests in a very short period of time. And there actually follows this predictable path from agriculture up to a forest stand. And you can, there's a little bit of variation depending on where you are and the soil type and some other factors like that. But you can pretty clearly predict what's going to happen to an old field as it turns into forest. So between years 1 and 3, you have, annual weeds, right? Ragweed is a big one. Broom sedge is a big, tall species. You can see it turning golden this time of year. And then that sort of succeeds to woody shrubs. And you'll see actually baby pines, right? We don't have to plant loblolly pine in the Piedmont. It seeds in that huge amount of seeds in all by itself. And other early successional species like sweet gum. And then you'll see the site slowly take over with trees. And so eventually, the canopy closes, right? Where the canopy of all the trees that have seeded in, those canopies touch, right? And so then you have a big loss of the herbaceous plants in the understory, and you have a closed canopy, usually pine forest here in the Piedmont. And then eventually you'll start seeing shade tolerant oaks and other hardwoods coming into that pine stand. They can actually grow in that shade that the pine generates, right? You never see baby pines underneath pines. They are shade intolerant. And then over time, that forest diversifies, and you can see a developing structure here at the end, towards the end of, say, 80 to 100 years. So this is a very predictable path, and we call this succession, right? So it's a succession of vegetation that you can predict following agricultural abandonment. So just to recap here, right? So this is what happened over much of the Piedmont following the Civil War, right? With herbaceous plants in the years 0 to 3, and then you have woody shrubs, pine and sweet gum. Right between 10 and 25 years, you've got the canopy comes to a close. Those canopies touch, so you have a big loss of herbaceous material, but you have a pine oak forest, and then pine oak forest, right? So you can predict the age of a stand based on the kinds of trees that are there. Right, when you have a pine canopy and oak understory, this is like much of the Schenck Forest and much of Umstead Park, right? You can say that it's 25 to 75 years old, and then beyond that, you have an oak hickory forest developing, right? So the pines are not as long-lived as oaks, and so eventually they'll start coming down in storms and other things. So a lot of the research on succession and that went into mapping this predictable pattern was done at Duke Forest by Catherine Keever and Elsie Quartermain in the mid-1900s during World War II. A lot of researchers who were men were off at war, and these two women did a lot of research at Duke Forest, working for Dr. Osting at Duke University. And Quartermain continued doing their research. They were actually both pretty long-lived. So what do these forests look like? So pine oak forest, you can see in the photo on the left that you've got still some broom sedge, that's kind of that golden colored herbaceous plant. And then you see these bushy early, pretty young loblolly pines. They're fast growing, shade intolerant, so they love these old field conditions. This is one of the reasons why we call it old field pine as a common name. And then over time, right, those loblolly pines shoot up and they reach maturity. You can still see they're at the edge of a field in the picture on the right, but their canopies are touching. And so talking a little bit about, for all of the forests that we learned park in late fall, and you can see that looking at the structure of this stand, the canopy is obviously closed, and you've got a nice mid-story developed, right? So you can see leaves from the forest floor all the way up into the canopy, which indicates that you've got mature trees, but also understory trees as well. So this forest structure changes over time. So depending on the age of your stand, you're going to have a different forest structure. Before canopy closure, it is kind of a weedy mess. It's not the forest you want to do your research in. It's kind of a tick fest. And then you've got, loads of, it's very thick. Canopies may be close together, and lots of weeds, broom sedge, ragweed, all that kind of thing. And then after canopy closure, the structure changes pretty significantly. You've got the trees, canopies come together, and so suddenly you've got a whole lot of shade in the forest floor. So there's a lot of herbaceous plants that can't deal with those kinds of conditions. And then you have to think about, this is, right, forests are dynamic, right? They seem like they don't change, but they just change on a scale that we as humans don't really see, because they're on a longer time frame than we are. Think of them as the Ents. So as the forest continues to age, you have shade-tolerant species that replace those herbaceous species on the forest floor. So you could have little pine seedlings, or not pine seedlings, but little oak seedlings and other hardwoods that are tolerant to shade, growing up and eventually reaching the mid-story. You also have loss of some of the canopy species over time. So how this forest structure looks really depends on the soil type. It can depend on disturbance, right? If there's often you'll have storm damage that can bring down parts of the canopy, and also depends on what species are in the canopy and how long they hold that spot. So here's another forest stand, right? So I'm just showing you lots of examples so you get a sense of what these Piedmont stands look like. So you can see, I hope you can recognize a lot of loblolly pine in this photo. And then I can see some tulip tree there. You can also notice that the understory doesn't have a whole lot of species. So that's, something that's pretty notable. And then, the species composition of the forest really depends on certain factors. So one factor that's really commonly used for Piedmont and mountain forests is Mesic forest versus xeric. So Mesic, right, translated means moderate. And so Mesic forest has a higher level of moisture. I'm saying here that it's less acidic soils with more nutrients. That's a kind of North Carolina specific generalization. So what I mean by that is that almost all the soil in the state of North Carolina is acidic to some degree. So less acidic means that it has more nutrients and more available nutrients in the soil. But it is still on the pH scale considered acidic soil. And then you've got xeric conditions, right? So xeric means dry. So these sites have less moisture. They're often more acidic or rocky. They can be nutrient poor. Also, this is where topography comes into play, protected sites versus exposed sites. You can imagine that it actually has quite an influence on the forest that develops. So a protected site might have a bowl shape, and we're going to talk about this more in the mountains, but they might be protected from winds, from storms, and things like that. Exposed sites, those sites are more prone to lightning strikes and also high winds. So for any of these forests that we're going to look at, you can see a Mesic version versus a xeric version. So let's talk first about the species that are present throughout the Piedmont, ones that are very, very common. So we have a canopy of pines, right? And so this is geography dependent. So here in Raleigh, we often have loblolly pine. We know that at the coast, as this forest type grades into the coastal plain, loblolly pine is the one that's most common. But as we get farther west and north, we'll have an increased component of shortleaf pine, Pinus echinata, as well as Virginia pine, Pinus virginiana, which actually extends much farther north. Right? These are shorter foliage needles. So those are species that we'll learn in lab. And then what do we have in the understory? So pine oak forest, remember, has a canopy of pines. The understory is a snapshot in time while this forest is developing. So in the understory, you'll have all shade tolerant species, species that can grow up. So this photo on the right, you can see, I think this is the Mountains to Sea Trail. Again, you can see there's the largest tree is a pine, and then you've got an understory of oaks and other species that are popping up. So if you're on a Mesic site, this is a site that's a little bit more moderate. It's got maybe deeper soils, they may be a little less acidic. There's higher availability, right? If you have less acidic soils, that means nutrients are more available. And so in these richer sites or Mesic sites, you would have additional species coming in. This is a pretty diverse area, right? Sweet gum, red maple, which can live anywhere, yellow poplar or tulip poplar, white oak, northern red oak, American beech, right, which is shown in the photo. This is Mountains to Sea Trail again, white ash and shagbark hickory. So these are common species that you'll see in the understory of these pine oak forests that are found on more Mesic sites. Also, these are the sites that have higher numbers of spring ephemerals. So if you go to Swift Creek Bluffs, right, there's a bottomland hardwood there, forest there, and alongside the creek. But as you get into the upland area, it would be considered a Mesic forest. And you'll notice that that translates into higher nutrients, which enable a higher diversity of species. So more Mesic sites, right, they're moderate, and so they're better habitat for more species. The Mesic forests often had less historical disturbance. They have a higher pH, higher nutrients, and more spring ephemerals. And when we're talking about spring ephemerals, I'm glad that I have this on here to define it, right? These are small wildflowers that completely complete their life cycle before the canopy leaves out. So in this photo here on the right, this is a beech tree at Swift Creek Bluffs, and you can see some really cute little trout lilies, erythronium, that are in the understory, right? So the idea behind spring ephemerals is that they grow in forests, right? But they complete their life cycles very early in spring. So they're spring, right? And ephemeral means they don't last for a very long time. So their idea is to complete, they leaf out, right? They only thrive in hardwood forests because when the trees have no leaves on them, they can capture that available sunlight. They come into a flower very quickly, they produce their seed, and they're often gone. Like often the leaves have disappeared by the time the canopy is leafed out in spring. So the whole idea of spring ephemerals is that they complete their life cycle before the canopy leaves out. So pretty slick, I think. When you're looking at xeric sites, this is a photo from Occoneechee Mountain State Natural Area. And I can tell that based on the little teeny cones that are in the photo, this is Virginia pine. And you can also see that the foliage is really short. So Virginia pine is one of the main species, but you also see understory species. You're going to see a lot more oaks that are more xeric sites. They can tolerate drought conditions. So chestnut oak, black oak, scarlet oak, right? These are also species. This forest type is very common at Hayne Rock State Park. Also sourwood, sassafras, and winged elm. So these are species that are drought tolerant, and they can hack these understory conditions in these xeric sites. Often you'll see more exposed ground and rock. There's not as many pockets of soil or soil nutrients available to support spring ephemerals. And so these are kind of dry areas. They don't have a whole lot in the understory, but there are some species that can live anywhere, right? Like red maple. So some of these species are, favor the drought tolerant sites. So for example, I would say chestnut oak and black oak are often found in these dry rocky sites. And then you've got spaces like red maple, which can live anywhere. So disturbance, right? So fire suppression over time, right? We've had a historic Forest Service policy, national policy of fire suppression. We have fires, we try and put them out immediately. We do not let them burn. And so this longstanding fire suppression policy means that Piedmont forests have a greater number of thin-barked species than they might have historically, right? So historically, these forests had more oaks in them, but because of fire suppression, the thin bark species were not taken out by fire. So red maple, American beech, and tulip tree. These are all thin barked species that are not fire tolerant. In the past, these forests might have had more oaks in them. And then we definitely have some damage from storms, right? So wind throw will uproot trees and bring them down. And that creates gaps in these forests and also microhabitats. So Piedmont of North Carolina, probably the most notable storm that we've had in recent history is Hurricane Fran, which was 1996. You can still see tip-up mounds and areas where that forest is still recovering following that really big storm, which had very strong winds and uprooted, it really devastated a lot of areas around this part of North Carolina. You can see here, this is a photo taken at Falls Lake on a prescribed fire that I was helping with. And, if you want to restore some of your oak forests in the Piedmont, you would conduct these prescribed burns. You can see the fire is very low, right? We did it during the wet season. So early in spring, you can see the trees have not leafed out yet. We just have pines with canopy there. So those clearing stands will tend to knock back things like sweet gum and favor oak regeneration. So then over time, right, you've got development, rapid urbanization has meant that a lot of these forests have been cut. And then also, the models that we're looking at for climate change predict higher temperatures for sure, but also drought as being more frequent in this area. So that may end up favoring some of those species that can tolerate dry conditions. And I want to go back just a little bit, right? So remembering that pine oak forest transitions into oak hickory forest. So all those species that I show in the understory, right, on Mesic sites, right, sweet gum, red maple, yellow poplar, white oak, northern red oak, beech, ash, and shagbark hickory, those species become canopy trees over time as this pine oak forests, right, the pines start dropping out. They might be susceptible to wind throw or storm damage, and then that opens up gaps that allows those other hardwood species to come in. Same thing on the oak hickory forest, right, with the drier, more xeric sites. Those species take over time. So that's just one thing I wanted to note before the end. And you can see this photo on the left. You can see that we have some mature species there. It looks like tulip tree and maybe white oak. And there's a pretty developed mid-story there. And then a more mature forest on the right. I know that photo was taken at Umstead with some really large, beautiful mature oaks. Again, not a whole lot in the understory, but now that you've got a canopy that is deciduous, you can have, there's room for more spring ephemerals early on in the season. So that's something that you can see early in the spring. So keep in mind, Piedmont forests are all a result of secondary succession. We are not looking at old growth forests in the Piedmont. And this follows a long history of land clearing, agriculture, and settlement. And over time, these forests develop structure, right? So, there's an initial flush. I took you through all the steps of succession, starting with herbaceous species, then leading to pine canopy closure, and then this development of structure over time as you have shade-tolerant species coming into the mid-story. When we look at Piedmont pine oak forests, that's a snapshot in time. Eventually, they will develop into oak hickory forests. And then finally, it's important to note that species composition in Piedmont pine oak and oak hickory forests all depends on site conditions. So a little bit more moisture and more protection results in kind of a mesic version of that forest. Drier, rockier soils that are more exposed sites, right? Thinking about topography will result in a suite of species that is more tolerant of xeric conditions or dry conditions.